Hello everyone, welcome to this session on Introduction to DevOps. Today in this session, we will be going through some of the most important concepts that you will need to know in order to understand DevOps completely. All right. So before we begin, guys, I'd like to point out that we have some people on YouTube and we have some people who have joined us on webinar. So the people on webinar, you guys are free to ask me questions as we move along in the session. So right now, if you have any questions, please let me know before we begin the class. Any questions, guys? Okay, so let's try this. Am I audible to everyone? Can you quickly give me an answer in the question box? Am I audible to everyone, guys? Okay, Shweta says yes. Others? Guys, am I audible? Okay, Achyun says yes. Abbas says yes. All right, guys, let's go ahead then. So, like I said, I welcome you all to this session, which is basically going to be on Introduction to DevOps. Let's go ahead and understand what all we'll be covering in this session. So, guys, we will be starting off with, the scratch. We will first understand what is software development, then understand how software is basically developed, and then understand why did we need a methodology such as DevOps in software development. After that, we're going to move on and start off with what is DevOps, followed by the DevOps lifecycle, and then we'll be concluding using, by understanding what are the various DevOps tools which basically make up a DevOps lifecycle. Right. So in this session, even if you are from a non-programming background, you will be able to understand clearly what is DevOps. All right. So let's go ahead and get started. So guys, first, in order to understand DevOps, you should be very clear with respect to what software development is. And only when software development is clear to you, you will be able to understand what is DevOps. So what is software development? So software development is basically a methodology using which you can develop software. For example, you and me, we are basically making use of this webinar today, or we are basically making use of YouTube today. So anybody who would have thought, let's create a platform like YouTube, would have thought about what features they have in YouTube, and then thought about how they can code their way in order to basically create a website like YouTube. Right now, it would involve obviously a lot of people. So it's a one-man's job. You can plan it easily, and you can develop slowly and steadily as you move ahead. But when you have a team of 50 or 100 or even more than that, if you have developers in your company, how do you tell those people that, or how do you basically sync all their work together in order to create one app which you basically want to publish? Which in our case, we are trying to understand how would have a product like YouTube be developed. So if you think about it, YouTube is a product of a company called Google, and Google has around, it has around 5,000 plus employees all around the globe, and they have various products. They have products such as Google Drive, they have Google Search Engine, and other products. So how would they align their teams to work in groups and create certain products is something that you are going to understand from the analogy of the process of what software development is. Okay, so let's go ahead and understand how a software is basically developed. So the process of through which a software is developed is basically called software development. But how do you go ahead and implement software development? Let's go ahead and understand that. So the whole process of software development, guys, is divided among 5 stages. First one being the requirement stage, then we have design, implementation, verification, and then maintenance. These are the 5 stages, or this is a process that we have basically devised through which by the end of the last stage, which is the very maintenance stage, we will basically have a usable software. Okay, so let's understand what these stages are one by one. So the first stage is the requirement stage. So this is the stage where you think about, okay, so I want to create a software which would look something like this. So in our case, we are thinking about, let's say, a software which is YouTube. So we want to go ahead and create a software like YouTube. So what I do is I basically approach some developers and I say, this is an idea that I have, and I want to create an app like this. So the developers will say, okay, great, so we can do that for you, but what are your requirements? What are the features that you want to add in your application? Right? So I tell them my features that, what I want a video streaming platform. I want people to be able to comment. I want people to be able to like or dislike a video. I want people to be able to log in to the service. So these are the features which I give to the developer. Then what the developers do is they basically go ahead and design, the architecture for this. Now, obviously, when I say I meet a developer, I'm meeting probably a person who manages all the developers in the company, right? And this manager has a knowledge of the whole technical stack, which will basically be required to create the app. So what he does is he understands your requirements in plain words, and then he basically designs, the architecture of the application, how it's going to be implemented, or how the features are going to be written in for certain programming languages. He thinks about all those things, and then he basically distributes the work among his team members, and that is basically the implementation stage. So the manager then basically passes down the work to the different people that are there in the team, right? And basically gives each person a certain set of tasks, which when he completes is going to basically be a part of an application, right? So that is the implementation phase. And once the implementation is done, once the software is developed, obviously in parts, then there is a stage called verification. Now, let's say I am a developer of that team, and what I've been given was that you have to create the login page. Let's assume. So when I create the login page, I'm done with it. So I will tell my manager, you know what, sir, I'm done with the login page. So if you want to check it, please check it. So he will say, okay, give it to the verification team, or give it to the software testing team. So the software testing team is now going to just check this one component, that is the login page, to see whether it is whether it is taking the correct inputs or not, right? Whether it is giving the correct outputs or not. And once the verification is done, then comes the maintenance phase. So before we move on to the maintenance phase, guys, there are a lot of things which happen over here. All the different components which are assigned to different developers are created. They are in the end integrated with each other, and then again a testing is done, as a whole product, as whether all these components are working fine with each other. And when they are working fine with each other, that's when the verification stage is complete. Once the verification stage is complete, then comes the stage of maintenance. So what happens in maintenance? So once the software has been developed, once the software has been made available to the public, the next step which happens is basically to maintain this software. So obviously this software might have some bugs. This software might need some new features. So fixing the bugs, adding new features, it's the maintenance phase of the application, where basically you go ahead and maintain the application. If it crashes, you go ahead and fix what made it to crash. If there are any new features required, you go ahead and add those features, etc. That's the maintenance phase, and this is the final stage, where an application basically goes. And this maintenance phase basically never ends, right? Until and unless you decide that you are not going to support this application anymore, the maintenance phase, it basically goes on. And this is, a very brief overview of how a software development, or how a software is basically developed. Now, having said that, it is not that easy the way I told you it is, right? There are a lot of things that are involved in each stage of this, what I just discussed, right? And in order to basically implement it, so software industry has been there for 40 years now, more than 40 years, I believe, right? So there are various implementations, or there are various alterations which has happened to, how we work today as a software company, how we develop software today, right? So along the way, there were a lot of methodologies which came up, which basically implemented the same software development lifecycle. So what were those methodologies? So we basically came up with first methodology that we came up with was with waterfall. Then we came up with something called as the agile methodology, and then we came up with something called as the lean methodology. Now, all these three methodologies, waterfall, agile, and lean, they basically implement the same life cycle. That is, they all follow this life cycle that I just discussed with you. But they have their own principles that they have added on top of following these stages. So what are those principles? Let's go ahead and understand. So waterfall versus agile versus lean. So first came waterfall, then came the agile methodology, then came the lean methodology. So let's understand what are the differences between these three. So guys, waterfall model, what it said was, it basically said that the whole life cycle of the software development, for a certain software, I will implement it at once. So if you tell me that you want to create a software like YouTube, what I'll do is, whatever features you want, I will start creating all those features together. And by the end of this life cycle, you will get the finished product. This is what the waterfall life cycle said. And it sounds okay, it sounds cool, it sounds good, right? So what could be the problem with that? Well, the problem was that, let's say I went ahead and told you that I need a YouTube application and I gave you 100 set of features that I need in that application. So you as a company, what you will say that, okay, you gave me a list of 100 features. I think these features will take some 6 months time for me to develop. So if this is January, which is running right now, probably by June end, I will deliver the software to you. Okay, this was there in waterfall model because every feature will be developed first. But I mean, as time progressed, this requirement became a lot of it became a lot of problematic for a lot of people. Why? Because let's say I want an application which will work like YouTube today, right? So I will go to developer, he will say he will deliver it after 6 months. But after 6 months, can you imagine how many competitors or how many people who probably have the same idea can get their own application up and running, right? So in the current age, time is money. Time is very important to everyone. The person who gets there first is the person who basically wins, right? So with that thing in mind, the waterfall model had this very big disadvantage that the time taken to develop the software was a lot more. And we wanted to reduce this time. So we came up with a methodology called Agile. And in this, what we said was, there might be 100 features that you want to develop, right? But I think there would be some set of features that you would want first, which would basically be the core of your application. For example, if you are trying to develop YouTube, what is the core of that application? The core is video streaming, right? So what if the developer tells you, you know what, let me do this, let me create a video streaming application, and probably the login feature, the like dislike feature, and the comment feature, I can add to this application as and when they're developed. So the first uh, part of the application, the video streaming part, I will make it ready and I will deliver it to you in 1 month. So after 1 month, you will be able to deploy your application. And after 2 months, probably, I will put a code out there which will enable people to add comments. Then after 3 months, I will add a code out there which will enable people to log in and then basically see the video. So that's how incremental the software builds have become. And this is something that you would have also noticed, in the modern applications that you see. For example, if you have used Facebook, or let's say if you have, I'm pretty sure every one of you would have used WhatsApp. So if you would remember some 7 or 6 years ago, if you were using WhatsApp, the blue tick option was never there. That is something which has been recently added, right? So when it was not there, still, I mean, the WhatsApp application was working fine, right? But as and when time progressed, people realized that, you know what, we need something, we need an acknowledgement that the person has actually read our messages, right? Or it could be that WhatsApp probably thought of adding that feature, but they thought it will take a lot of more time. So they basically made you available an app through which you can do messaging to each other over the internet. And after that, they have added features. So even statuses were not there in WhatsApp, but they are now available. I think they got available some 4 years back, right? Similarly, there are a lot more other features which have been added to WhatsApp, which were not there before. So this is an incremental way of, creating software where you decide what features you set out first and what features you want to add later based on priority. So this was the agile methodology, right? So this basically helped us to achieve we basically got softwares a lot faster by using the agile methodology. And then came lean methodology. So in lean methodology, basically, it was all about uh, internal optimizations. It was all about minimizing the time a team is taking to create a software. And what time are we trying to minimize? We are trying to minimize the time which the team is spending with each other. Let's say if you do a lot of meetings, right, that basically makes our productivity go down. So the lean methodology basically was an extract of agile methodology. It did everything what agile did, but at the same time it focused on not wasting a single minute while you're working. Okay, so it's a principle. So there's not much improvement in lean. It's just that wherever we can save time, we did. And this again, led to a revolution in the software industry where now instead of spending time in meetings, everything was basically, made fast using softwares like Slack, using productivity apps. You used to basically go ahead and make your time more productive. So this was the lean methodology. Okay, so by the end of lean methodology, we basically out all the extra time that we were taking to get a software delivered, and at the same time the time that the software used to get delivered in probably 6 months or 7 months were now reduced to 1 or 2 months. So it sounds too good, right? So what was the need of coming up with a methodology called DevOps? Let's go ahead and understand that. So with this, the problem between customers and the software company was solved with the basically inclusion of methodologies like Agile and Lean. So customers were now very happy with the software company. They said, you know what, you are giving me the software a lot faster and you're giving me according to the features that I require, and this is what I need. So thank you for this. And hence everything went well. But what basically made us to come up with a software methodology called DevOps? So why do we need DevOps? Let's go ahead and now understand that. So guys, the problem between the customers and the company is solved, but the problem between developers, the internal team is still there. So internally, our company, the way it functions, there were still a lot of things which could be improved, right? And what were the things? So probably if you think about how software is developed, there are a lot of teams which basically work with each other. There is something called as a developer team. There is something called as an operations team. There is something called as a QA team. So all these teams work together to basically build a product. Now, what was happening was the communication between all these people were basically a lot misleading, were basically not productive, and because of that, there was a lot of disjoint between team members, and they were not able to understand how to solve the problem. What was the disjoint? Let me go ahead and make you understand using an example. So let's say I, as a manager, gave the developers the job of creating the software, and I basically gave a developer the job of creating a login service. Okay, so the developer basically started his work and he created the login page. And what he did was he basically gave this page to the operations guy, saying, you know what, the login page is ready. Can you please go ahead and test it? And if it is good, please deploy it on the main server. Right. So the operations guy tries to run that login page on a system, and he's not able to run it. There is some error that he's getting, and without getting into what that error is, he straight away tells to the developer, you know what, I tried running it on my system, but it is not running actually. So you need to check there is something wrong with your code. Okay, but the developer says, if it's not running on your system, that is not my problem. It's for running fine on my system. So why should I go ahead and actually debug something? There's something wrong with your system. Please go ahead and check that, and then probably you can get the software running. But the operations guy said, it's not only my system. If I'm deploying it on the production system as well, if I'm deploying it on the main server as well, still over there the code is not running, right? So over here, whose fault is it? It's not the developer's fault. It's not the operations guy fault. But still the problem is arising, right? And the developer is also right in his own way, where he says that when the software is now running on my system fine, why can't you make it run on the main server, right? And because of this, there was a lot of back and forth between the development team and the operations team, where the work is still complete. The work is complete, but they are not able to figure out what exactly the problem is, because of which the software is not getting deployed on the main servers. Okay, and this impacted efficiency. This impacted on the deadlines. This impacted on even the human factor, wherein people get stressed in an environment where they probably are not able to feel productive throughout the day. Okay, and this is exactly why we needed DevOps. So this problem was solved by DevOps. This DevOps, using the DevOps methodology, we were able to solve small things like this, where code is running on one system, it's not running on the other system. There was a lot of human communication required. If my code is done, I will have to give it to the developer, the operations guy. The operations guy will then try running it on his system. If it runs on his system, we will log into the server, then deploy it over there. So there was a lot of human factor involved over here. And at a time when we all are working 24/7, most of the organizations work 24/7. People are working in shifts, right? So it is very difficult to make everyone understand in different time slots what you want to do. Let's say you're working according to your pace, and your work got completed at 12 a.m. in the night, let's assume. So for you, nobody will be available at 12 a.m. in the night to check your code, right? So all these problems had to be solved, and the best solution that we could come up with was DevOps. Okay, so what is DevOps exactly? Let's go ahead and understand. So before we get into that, what is DevOps and how it is basically different from the traditional IT? Let's go ahead and understand that with respect to the features, or let's say with respect to the problems that DevOps is solving. So in while we were not using DevOps, it seemed very less productive. The work seemed to be very less productive to us. But with DevOps, there was more productivity in the team. Right? In traditional IT, the team that we basically were developing, they had to be very skilled, right? So everyone had to know everything. While I was basically hiring for people when I was not using DevOps. But now it is very easy to hire people because I'm hiring people for a very specific job, right? Third thing is more time was invested in planning when I was not dealing with DevOps. And now with DevOps, I just start executing things by dividing each task into smaller things and then assigning it to people. And finally, it was difficult to achieve target or goal because of a lot of inefficiencies which are there in the team. But with DevOps, most of the deadlines are now met when you are working in a software development environment. So this is what could be achieved with DevOps. And now let's answer the million-dollar question, which you all are here for, that what is DevOps? So guys, DevOps is not a tool. It's basically a methodology. It's a fashion. It's a revolution, which basically tells a company or it tells a team how to basically work, right? And this methodology has been devised using various tools which were available at that time. So they made a combination of tools and they said, if we use these tools in combination with each other, we will be able to solve most of the problems that we are facing right now, right? And they said the use of all these tools together, we will call it DevOps. Why? Because dev, which means developers, and ops, which means operations, can come together using this particular methodology, and hence the name DevOps. Okay, so what is this DevOps lifecycle which basically saved the day? Let's go ahead and understand that. So guys, these are the stages which we discussed earlier as well when we were discussing about the software development lifecycle. You had the requirement stage, then you had the implementation stage, then you had the verification stage, and then you had the maintenance stage. So now what we do is we basically combine all these stages and we say that each stage will be basically handled by a software. So now if you have to plan and code, that can be done using tools for continuous development such as Git and GitHub. If you have to test the tools, those tools can be tested using tools like Selenium, like Maven, which can be built and the software can be tested. And once the software has been tested, there can something be, there will be a software in between which will automatically pick up if the software, if the test is passing, and it will deploy it on the production server, right? And while it is deploying it on the production server, it will ensure that whatever softwares are there on the developer system, all those softwares are also automatically installed on the production system. So there is no problem of software running on one system and not running on the other, right? So that is called continuous deployment. And finally, there was also a tool which could also help us in monitoring the application so that nobody has to sit 24/7 and understand if the application is working or not. There will be a software which will check the application whether it's available or not, or if it's working or not. And in case it is not working, it will send out a notification, it will send out an alert either through SMS or email that the application is facing any malfunction. Okay, so that was continuous monitoring, right? And this life cycle together, it's basically called DevOps. So how does it look like on a piece of paper? So you can imagine it like this, that with a software in place where I will be uploading all my code, and where I can do discussion whether the code has been written correctly or not. That particular software is called a version control system, right? And the examples of this could be a lot of software such as GitHub, such as GitLab, such as other version control systems which are out there, even SVN, which is yet another version control system. So all these systems can be used to store software, without wondering whether any changes that I'm making to the software, whether that code is also being saved or not. So with version control system, we could save histories of software. How did the code look like on in August? How did the code look like on 25th September? How did the code look like yesterday? What changes did you do yesterday, which with respect to the code which was there on 25th August, right? So all these things could be tracked line by line, word by word, everything could be tracked what you are making change in the code, right? So that was the version control system to you, which was GitHub or Git software that we know of, right? Then we came up with the code integrate all these tools. So now I did not have to rely on any other team member to be available. What I can do is put the software on a version control. This continuous integration software will see, okay, there is a new code which has been written. It will pick up that code, install the softwares which are required, and once the testing server runs this code, what it does, it basically runs automatic test cases over the software. Now, what does that mean? That means that let's say you're running the test cases and you get to know that some, let's say we are testing the, so how would you test it? Put some random inputs, check what the output is, you put the correct inputs, see what the output is. So similar to this automatic suite could also do. It could automatically have inputs given to the software and outputs checked whether they are correct or not. And these are basically created by testers, these automatic suites, right? And these could be run automatically at any time of the day and without the intervention of testers on the software which is being pushed by the developer. If the software is basically passing all the test cases, then it will be told to the continuous integration software that, you know what, the code which came in is correct. So you can actually go ahead. You can then go ahead and automatically deploy it on the production. So with this developer, with asking 10 different people as to whether their code is correct or not, automatically got from a testing server, even if the software fails. So let's say some test basically failed when the software was being checked. So in that case, continuous integration software that so then we will not push it onto production. We email to the developer who pushed the code that this is the problem with your code. Please fix the error and again try to submit. Again, if he submits the code by fixing it, if the test, it will be deployed on production server automatically. And this is exactly what DevOps is, guys. DevOps is the methodology in which you use a combination of tools to achieve an automation like this, wherein human intervention is not required. If one guy's job is done, he could basically push the code in the system, and he could, or let's say a tester's job is done, he will push the automating test case in the system. And when the code will come, this test case will do its job and it will give the reply automatically to the developer. This is what DevOps is. So we have not talked about any tool yet. We will do that in a couple of minutes. But if you have any questions so far, please let me know. Any questions, guys? Anything that you did not understand, and I would be happy to answer. Questions? Is everything clear up till over here? Is everything understandable what I just told you? So Kamal is saying, how can we set the criticality of test cases? Well, Kamal, it is all customizable, right? So you can set, let's say, you can say that it could be that when you are clicking on the submit button, and let's say if you are talking about the login application that we are testing, let's say the inputs, the inputs are being taken correctly. If you're giving a wrong input again, it is giving you proper messages. But it could be the case when you're submitting, probably the graphic which is coming is not correct. So if the graphic which is coming is not correct, in that case, you can prioritize each test case or each output which is failing at what level of, what level of failure it is. And using simple if else clauses, you can specify if the test case is equal to, let's say, P3, which is priority 3, then you can actually deploy it on production and give a warning message to the developer that this has to be fixed in the next release. So something that such as this can also be came up with in case there's a release that is supposed to be done urgently, and because of small bugs, you do not want to delay it. Okay. One more question from Kamal is saying, as without which code should not move to prod and immediately be notified to developer. Well, Kamal, so in the continuous integration software that we are discussing, you can specify, like for example, when we are working with a version control system, you will understand when we read more about them that there is something called as branches, right? So at each branch, what the continuous integration server has to do, which can specify. So if a junior developer is just having the access to push the code to a certain branch, the continuous integration server will also do the action according to the branch. So let's say something is being pushed to master branch. So in that case, we know that the master branch, only probably the manager of the team can push, who's the reliable person. And in that case, if a code is being pushed to the master, in that case, what will happen is it can basically have the clause of pushing it to production in case the test cases pass. Right. So that is the kind of customization that you can do in the continuous integration server. That is always available to you. Okay, Maudley is saying, is DevOps the DevOps is like a developer that can do system administration tasks. Correct me if I'm right. To an extent, Maudley, yes. So we want to remove the dependency between the developer and the operations team. Now the operations team can come up with test cases. They can come up with the correct softwares that have to be installed and configure them in the continuous deployment softwares or in the monitoring softwares or in the testing softwares that can automatically be done by the operations team. So they don't have to rely on developers to ask them, when will you be pushing the code? They can be done with their job, and developers can do their own job of pushing the code and checking whether it's working correctly or not. So because you have deep teams, that is the second DevOps methodology. Okay, Kamal is saying, okay, got it, thanks. All right. All right, guys. Any more questions before we move along? Any more questions? Is everything clear? If let's go ahead. Any more questions? All right, so if there are no questions, let's move ahead. So now that you've understood the life cycle of DevOps, now let's understand the various tools which will basically be used to implement this life cycle. So guys, these are the various tools that you will learn in this DevOps course. You will learn, so the continuous integration tool, which is called Jenkins, is the main tool, is the heart of the DevOps lifecycle. Then you have something called as Docker, then you have something called as Kubernetes, Puppet, Ansible, Git, Nagios. So all these tools you will be learning as part of this course. And by the end of it, you will be able to implement your own DevOps lifecycle by a combination of all these tools. Okay, so giving a brief about each of the stages that we have discussed in DevOps, the first thing was continuous development. So for continuous development, we will be using a tool like Git, which will basically help you to version control your software. So you will have something called as branches, which will be logical isolation of different stages of code: reviewed code, not reviewed code, final code, code which is ready for release, etc. So all this logical isolation can be done. And at the same time, like I said, you could see different versions of the code at different stages. For example, if you want to see the code on 25th August, you can go ahead and see it. If you want to check out what is the difference between the code which was there 2 months back and the code which is there today, what are the different lines which have been changed, who changed those lines, that answer, each and every of those answers can be given to you by the Git software. Then we have something called as continuous integration, which is basically possible using a software called Jenkins. Like I said, it is going to be the heart of your DevOps lifecycle, and it is going to integrate all the tools which are there in the DevOps lifecycle. This is the tool which is going to help you doing that. Then you have something called as continuous deployment, right? So this will be possible using two types of tools. So the virtualization part of it, the containerization part of it will be handled by Docker, and the software deployment part will be handled by Puppet or Ansible. Similarly, you have continuous testing, wherein I talked about creating automated test cases. This will be created with the help of the Selenium framework. This can be developed on top of either Java or Python, right? And finally, you have a stage called continuous monitoring, which is basically which can be done using any monitoring tool. But in this course, we will be learning how that is possible using Nagios. How can you monitor each and every software which is running on a system, right? And trigger notifications or alerts or emails or SMSs in case any of that software goes out of line, right? So that we will be learning using the Nagios software in this course. All right. So finally, if you can see the life cycle that we saw earlier, this is how the life cycle will finally look like. The monitoring will be done by Nagios. The version control will be done by GitHub, right? The continuous integration will be done by Jenkins. The continuous deployment part will be done by Puppet and Ansible, and the testing part will be done by Selenium. So guys, this is how you can go ahead and implement the DevOps lifecycle. Okay, so I think now let's come to a stage where we all can basically answer questions with respect to what we just learned. So let me go ahead and pick up some questions which you guys can go ahead and answer. Okay. So the first question is, DevOps methodology was focused on solving the problems between the customers and the software company. Is this true or is this false? Let's see if you guys can answer this. Okay, Fab says it's true. Okay, others? What do you think is the answer to this? Kamal says it's false. All right. Others? Belita says it's false. Okay. Come on, guys. We have more questions to cover up. Is this true or false? Shweta says it's false. Okay. Okay, so all of you are right, except Fab. So the answer is false. And the reason for that is DevOps, as the name suggests, solve the problem between the developer team and the operations team. So that would be the correct answer. Okay. Eduardo says false. Yes, you are right. Eduardo as well. Okay. Next question is, which life cycle stage in DevOps helps in transition from one stage to another? What is the heart of the DevOps life cycle among all these stages? Okay, Kamal says the answer is D. Okay. Shakila says it's D. All right. Fab says it's D. Okay. Eduardo says D. Sanjeet says D. All right, guys. So all of you are right. I'm very happy with all of you. You guys paid the utmost attention. So the answer is continuous integration. Continuous integration is the heart of the DevOps lifecycle. This is the stage which is going to connect each and every other stage in DevOps. Okay. All right. Final question. Which tool among the following will help you in containerization? Now, we did not focus on this much, but let's see how many of you were actually paying attention. Okay, Andrew says D, Balita say it's D, Fab says D, Shakila D, Eduardo D, Kamal Docker. Awesome, guys. So I think every one of you is absolutely correct. The answer is Docker. All right, guys. So with that, we come to an end to this session. And thank you all for joining in today. I hope this session was useful to you, and I hope you have learned something out of this session, right? Now, most of you would be wondering what is the next step for this. So for that, what we are going to do is we are basically going to introduce you to a training page, which is basically the DevOps certification training by Intellipaat. So you can basically go ahead and you can go to intellipaat.com and you can go to the DevOps certification training page and you can go ahead and check out our DevOps page. We have a batch starting 6th October. If you want to continue learning with us, you can actually go ahead and enroll in any of our batch. We run batches on both weekdays and weekends. So if you are interested, you can go ahead and join a batch for that. All right. Uh, so I have a colleague with me who's going to join in, guys. So just give me a moment. They're going to explain you more about the course. Just give me a moment. I'll make them join. All right, guys. So let me go ahead and give you an introduction to like how you can go ahead and or why you should actually go ahead and learn a course like DevOps from Intellipaat. So, guys, if you can see over here, we basically offer this DevOps course, and we basically teach this course live. So you will have this training the same way as we are teaching it now. It's going to be a live instructor-led training where you can ask your questions live to the instructor, and he will be answering it for you. So in this course, it will be a 33-hour long course where we are going to teach you 11 modules or 11 tools in DevOps through and through, right? We will also be providing you self-paced videos. So like I said, we have a live batch which starts on weekdays or weekends. It is up to you which one you choose according to your preference. If you're free more on weekdays, you can opt for a DevOps batch on weekdays. If you're free more on weekends, you can opt for a batch on weekend, right? But once you enroll for the course, we basically give you a set of pre-recorded videos as well, which are basically called self-paced videos. So in case, let's say you want to go ahead and learn something first and then learn something later, and you don't want to go to our according to a live schedule, you can also do that using a self-paced videos. Right. We also give you a flexible schedule, which basically means that we understand that you as professionals, you might not be free every weekend or every weekday to attend the class, right? So if let's say you miss a class and you want to reschedule it to some other day, so like I said, we run batches every week, right? So we can schedule you to any other batch which is also going to run the same class for you, right? So that's going to be flexible schedule, right? Apart from that, the main feature that you get with this training is 24/7 support, which basically means like, let's say I'm an instructor, and if you're learning from me, I will probably be available only for the class that I'm taking, your class for. So I will not be available 24/7 for you. But what Intellipaat has done is they have basically appointed, technical consultants in their team, which are available round the clock and who are expert in this technology. Well, they might not be, a working professional like me who works on DevOps day in and day out, but they are people who are well versed with the course content. So they know all the assignments, they know all the hands-on, they know all the projects that are part of the course. So in case you have questions with respect to any concept, with respect to any assignment, with respect to any project that you want to go ahead and clear off, you can call their 24/7 support line, and they will be able to help you out then and there. So even if let's say are a person who studies in the night or who studies early morning, you don't have to worry about the timing of when Intellipaat is working. You can call them anytime, and a technical consultant will be made available to you to speak to you with regards to the doubt that you have. So that is 24/7 support. After that, what we also give you is we also give you 60 hours worth of project work and exercises, because now DevOps or cloud is a profile which basically expects experience, right? So you will say that I'm not from programming background, I'm from so and so background. How will I portray myself as a person who is experienced in DevOps? So the answer for you is in this particular line over here, that we will be giving you 60 hours of project work and exercises. And if you do all the exercises, all the projects, all the hands-on, all the quizzes that we give you, we guarantee you that after doing this course, you will be equivalent to a 1 year DevOps professional, a person who has spent 1 year in the company. You will be equivalent to the skill set of that person, right? And even if a company is asking, where did you work on DevOps before this? You can show them all the projects that you have done, and you can tell them that these are all the projects that you have done as a DevOps engineer while you were learning DevOps. And that would actually make sense, because all the exercises, all the projects that we have basically curated in the course, they have basically been created with the help of instructors who are real life DevOps engineers, and they have given us these questions that they face day in and day out in their companies, and they want people like you to solve it who are learning DevOps, so that you get a taste of how you are going to basically face problems when you're working in office. Okay. Apart from this, if you want to go through the course content with this, if you want to go through all the tools that we teach, These are all the tools that we teach. If you want to have a list of this, we teach all these tools from Git, Jenkins, Maven, Puppet and Ansible, Kubernetes, Docker, Nagios, Terraform, even we will be teaching you Docker as a service, Docker Swarm as a service. Docker Swarm and Kubernetes basically do the same thing. But why we've included both of them in this curriculum is because most of the job descriptions, they either prefer Docker Swarm or they prefer Kubernetes. So it's better if you know both tools, so that there is no job description that you cannot apply to. Okay. Apart from that, if you have any more questions, you can just head out over to our FAQ section and you can find it over here. If you want to look at the projects that we have included in the course, you can just go to this section, DevOps projects which are covered, and here you will find the list of all the projects that we are basically going to give to you, right? The next question that people have usually is, what about job assistance? So we also offer job assistance on each and every training of ours, which basically means that, let's say you're done with the course. So now we will help you in creating or building your resume. We will help you in applying for jobs. We will help you by getting you interviews. How? Because we as a company, we also operate in the B2B space, which basically means rather than, we do also teach individuals like you, but we also get training requirements from companies directly, right? So we train their employees as well. So these companies, they always are looking out for more professionals, that they want to hire, which can be a replica of their existing workforce. So let's say today we teach thesis on around 200 employees on DevOps. So tomorrow, let's say 20 of their employees left. So they are always on the lookout of more people who probably are knowing DevOps earlier rather than getting them trained in their company, because obviously that incurs cost. So that's why they basically reach out to us, because they know that we train people every week. So they ask us that who are the best people in your training who will know DevOps the best. We want to interview them, right? So that's how we basically forward your resumes. And for that also, we would need help from your side too. We would only forward the resumes which probably are solving all the assignments, all the projects. Reason being, see, if we are training 100 people a week, obviously all those 100 people, if we give for interviews, even TCS will not be able to handle them. So what we do is we only choose out the best people so when I say the best, the criteria is that you have done all the projects, you have done all the assignments, you've attended all the classes, and only then, if you have passed this criteria, we forward your resume to the company which is going to take the interview, and your interview is scheduled then and there. So we also help you. So since you would also apply from your side, we would also help you in resume building, because there are some techniques using which you can make your resume stand out. And I'm not just talking about beautification, I'm talking about the fact that a lot of companies use HR softwares, right? They use keyword researching tools and they search for just keywords, and in these softwares, the resume basically gets shortlisted. So how to get the right keywords in your resume, that is also something that we are going to help you out in. Right, so this was an overview, guys, that we give to you as a DevOps course. And in case any of you are interested in joining the training, you can let us know. So probably people who want to call back, they can mention in the question section, and I will initiate a call back immediately after this session. And anyways, even my course advisors are basically going to reach you out for the feedback for this session. And if you're interested, you can let them know about your interest, and they can also help you out in getting availed this training. So anyone who wants a quick callback, they can let me know, and I will forward the request to my course advisors. Okay, Nikita says she wants a callback. All right, Nikita, we'll do that for you. Sejal, she says she needs a callback. All right, Sejal. Okay, so I can see a lot of you have raised out the request. So what I'll do is I'll just copy paste these names into an Excel sheet, and I will just forward these to my course advisors, and they will be reaching you out after this session, guys. So it was nice talking to you all, guys. I hope you guys have learned something new, right? We hope this session was useful to you, and if you want to continue your learning into DevOps, if you think this is something that you want to pursue, please go ahead, give us a call, and we'll be helping you out. All right, guys. So with that said, have a great day ahead, and goodbye. Okay, I can see Sanjeet and Shweta have also dropped in a message. All right, guys, we will reach you out.